Hello everyone, in this video tutorial I'll be taking you through wireless sensor network. Specifically, we'll be studying sensor mode platforms. So here, wireless sensor networks are composed of embedded systems which are capable of performing IPC. What is IPC? IPC is interacting with their environment, and in order to do this interaction they need sensors. So first, I stands for interacting, P stands for processing of information locally. So these modes will be having their own CPU, memory and other utilities to perform the data locally. And the last C in IPC stands for communication. So this whatever processed information is there, it has to be communicated, it has to be conveyed wirelessly to its neighbors. So wireless sensor networks are composed of embedded systems that are capable of IPC, where first I is interacting, second is processing, and third one is communicating. These sensor nodes consist of three main components. The very first component is wireless modules. The second component is a sensor board. The third component is a programming board. So now let's take up one by one. This wireless module is the key component of a sensor network, as they possess the communication capabilities. Only because of this we can achieve the third capability, that is communication. Followed by, these wireless modules also have their own programmable memory. And this mode, so wireless modules are also called as modes. These modes consist of a microcontroller of its own, transceiver, power source and memory unit, along with few sensors. And example for these modes are Mica, Cricket, Mica Z, Iris, Telos, Sunspot and iMote. Then the second component is a sensor board, and this sensor board is mounted on the mode, and this sensor board can be used for embedding multiple sensors. And this sensor board may also include a prototyping area that which can be used to connect the custom made sensors. Sensor board may also include MTS 300 or 400 and MDA 100/300, and these can be found in Mica family of modes. And the sensors can be integrated to Telos as well as Sunspot platform. And the third main component is the programming board. Gateway boards provides multiple interfaces including Ethernet, Wi-Fi, USB, serial port for connecting different modes to industrial network or laptop. These boards are used to program modes or gather data from them. So such kind of boards are actually called as programming boards. And example for these programming boards are MIB 510, MIB 520 and MIB 600. So MIB 510, 520, 600, and in order to remember this, just remember Men in Black. Particular platforms need to be connected to programming board to load the application into the programmable memory. So here particular platforms are actually needed, like it can be Tiny OS, or it can be Light OS or Sunspot. And the Sunspot is a Java based OS, Java based virtual machine. So such kind of platforms need to be connected to programming board to load application or whatever code we write into the programmable memory. So this is about sensor node. And then we have low end platforms. So as the name itself indicate, these are low end platforms, and low end platforms are basically deprived of their processing power as well as communication power and onboard sensors. So low-end platforms are characterized by their limited capabilities. They are limited in what all fields: processing, memory and communication. But we need these low-end platforms because of this envision. What envision? These platforms are envisioned to be deployed in large number in wireless sensor network to accomplish sensing task as well as providing a connectivity infrastructure. So they are mainly used for sensing task and connectivity infrastructure. Example are in Mica family, and this Mica family board is from a company by name Crossbow, and this consists of different types of low-end platforms like Mica, Mica Z, Mica 2 and Iris modes. And over here each node has a 8-bit AVR microcontroller or Atmel microcontroller whose speed is from that whose operating speed varies from 4 to 16 megahertz, and they are associated with a flash memory of 128 to 256 KB, and they are also equipped with trans receivers that which operate at a data rate of 40 kbps at the bandwidth of 916 to 433 megahertz, and this Mica 2 operates at 40 kbps around 433, 868 and 916 megahertz bandwidth. Then we have the third category, that which is not into Mica family, that is IEEE 802.15.4 WPAN wireless PAN. So under this we have Mica Z and Iris nodes that which operate at 250 kbps data rate at a bandwidth of 2.4 gigahertz. So as you can see here, there is a drastic increase in the data rate, that is 250 kbps compared to that of previously available 40 kbps, and this is operating in terms of gigahertz bandwidth, but whereas these are operating at megahertz bandwidth, and they are associated with the RAM size of 4 to 8 KB, data memory of 512 KB, and they do also have 51 pin connector for connecting additional sensors. In a similar way we have Telos mode or T mode, and this is similar to Mica Z. So the Mica Z board that which we went through just now, Telos is again from Crossbow company, and whereas T mode is from Centilla. So they are associated with larger RAMs compared to that of previous category, so wherein we had just 4 to 8 KB, but whereas here we are having 10 KB of RAM, and example is MSP 430 microcontroller, whereas these were using 8-bit AVR microcontroller or Atmel microcontroller, and this also includes light sensor, IR sensor, humidity and temperature sensors, along with a slot for USB connection, and they also provide 6 to 10 pin for additional sensors. Then we have one more category after this Mica family as well as Telos mode family. We have the third kind, ICE, and this is similar to that of previously studied Telos B mode, that which is from Crossbow, and these are 16-bit microcontroller, a higher bit microcontroller compared to that of Mica family, because Mica family were of just 8-bit, and here they are having a higher program memory as well as data memory. And as you can see here, it has two separate memories, one for program and the other one for data, because of its memory architecture using Harvard kind of memory architecture. So Harvard kind of memory architecture is where memory will be divided into program as well as data, so that it can overcome the drawbacks of von Neumann memory architecture. So the program memory is of 60 KB, and whereas data memory is of 2 KB. So obviously the program will occupy more space, whereas data that which is used for programming will be less, and hence less memory will be allocated for this. And it has a few sensors like compass, accelerometer, temperature sensor, light sensor, and pressure sensor. And it also has RS-232 for slot for serial programming, and it also has TR, that is transceiver 1001, and it has different power consumption modes. That is, it makes use of 14 milliwatt power for receive mode, and 16 milliwatt for transmit mode, and 15 microwatt for deep sleep mode. Here you can see the power saving scheme. This is in terms of just microwatt. The platforms has RS-232 serial interface for programming. Low-end platforms are used for sensing task. Multiple hop network for connectivity. These low power microcontrollers and transceivers are used to bring down the cost and energy consumption of the distributed wireless sensor network architecture, and they are all based on ISM frequency band, because it is of unlicensed and it can be used freely for communication. Then we have high-end platforms that which are of higher processing capability, and they also have additional features, and let's see what all features it has. So additional to sensing, local processing, and multiple hop communication, wireless sensor networks requires additional functionalities for which low-end platform devices are not suitable. So additional functionality includes network management, multiple communication protocol support, and the third one is storage hubs. The first example for this high-end platform are Stargate. So this is a high-performance platform designed for sensing, signal processing, control, network management, and example for under Stargate is Intel PXA, that which makes use of RISC processor, and it has flash memory in terms of 32 megabytes and SD RAM of 64 megabytes, and it also has onboard connector for Crossbow Mica. And next we have Bluetooth IEEE 802.11 cards, and its roles are, it acts like wireless gateway, and it can also act like computational hub, and the third feature of that is medium resolution multimedia sensor. It also includes this sensor. Then we have iMote and iMote 2 high-end platforms, and these two are developed again by Intel. So the previously we have already been through this PXA, that which was of RISC kind of processor, and here we have this features of this iMote are that it's a 8-bit microcontroller, operating frequency is 12 megahertz, and it is based on ARM7 processor, and it has a Bluetooth radio, and it has a RAM of 64 KB and flash memory of 32 KB. So that was about high-end platforms or devices. And then we have standardization efforts. Why standardization is actually important is, so just now we have seen that there are a lot of devices from different companies ranging in different features. So thereby we have a huge heterogeneity of sensor platforms and compatibility issues in envisioned applications. Hence standardization is necessary. So because of this heterogeneity, compatibility issue will arise, and hence it is envisioned to have some standardization so that we don't face this compatibility problem. And in order to solve it, a committee called IEEE 802.15.4 body was formed, and this was specifically for slow data rate wireless transceiver technology. So these are specifically for slow data rate because in wireless sensor network the data rate is quite slow, and that is why this committee was formed. And along with that, it should also have longer battery life and low complexity. And this thing operates in 3 different bands. One is 2.4 gigahertz, second is 915 megahertz in America and 868 megahertz in Europe. And these 2 sub-gigahertz they operate on physical layer using binary phase shift keying, whereas 2.4 gigahertz, that which is used globally, makes use of this physical layer makes use of offset QPSK, quadrature phase shift keying. MAC layer provides communication for star mesh and cluster tree based topologies with controllers. Transmission range of nodes will range from 10 to 100 meters. Data rates around 20 to 250 kilobits per second. Bluetooth and WLAN technologies are not suitable for low power, so thereby 802.15.4 makes use of this ZigBee and wireless HART, and we have one more technology called as VINA are suitable for low power, and there is one more technology called as 6LoWPAN, that is that which implements IPv6 for low power personal area network, and this provides compatibility between wireless sensor network and existing IP network, that is internet. And under software, similar to that of hardware, we have software where in addition to hardware platforms, software platforms are also developed, and most accepted platform is TinyOS. It's an open source OS defined for wireless sensor network. This TinyOS has component based architecture, and it also has event driven execution model. So these 2 features minimizes the code size and provides a flexible platform for new communication protocols. This component and its component library consists of new network protocols, distributed services, sensor drivers, data acquisition tools, and it also comes with its own simulator called as TinyOS simulator, short form TOSIM, and other OS that which are available are LightOS, that which provides multi-threading feature, and it also has dynamic memory management system in it. And we have one more variant called as Contiki OS, that which is again an open source multitasking OS built specifically for Texas Instrument MSP 430 related boards. And then we have Sunspot, that which is not an actual OS, but it's a virtual machine based on Java.